And welcome to the Industry 4.0 weekly podcast. I am your host, Walker Reynolds, and we are live today. We are actually live. You will be happy to know this is not a pre-recorded podcast. So how's everybody doing? Let me check in here, see everybody dropping in. Hey, Mario, how's it going? Amro, Carrie, Cheryl, and Walker. Today we're going to talk about MES, a little bit about the unified namespace, a little about the MES, but it's our first live podcast in quite a while, and it is very good. Suraj, say hi, sir. It's very good to be back. Couple of just quick announcements. Let me just go through these announcements super fast while everybody's coming in. Hey, Mark Mamenga, what's up, buddy? So I'm going to touch on the Shot Classic here in a second. So we have decided not to send our entire team to ICC 2022, but we are sending, I think, 6 people. So if you guys are going to go to ICC, say hi. I will be there certainly for one day. I probably won't be there for the whole conference. The last few years that I've gone, I've generally gone in, been there for one day, said hi to a bunch of people, and then left. And I'll probably do the same thing today. So I'll probably be there one day. As soon as we know which day I'm definitely going to be there, we'll announce it and let everybody know when we're going to be there. JP, what's up, brother? Monthly mentorship call was last Friday. I actually did it from the Shaw Classic, from the hotel. At the Shaw Classic, we went over some MES elements because we've got the big MES Bootcamp coming up in September. I'm actually going to answer some questions. There was actually an email I got in from a good friend I'm going to read that email and kind of comment on it because it's actually got some really good information in it about MES. Mastermind. The next mastermind session is this Friday. We're going to be going over MES and the unified namespace. We're actually being talking about how we map certain items in the MES or in the unified namespace for that are MES capabilities. And the advisory board meeting is tomorrow. So you guys have any questions, anything that you want brought up in the advisory board meeting, that is in terms of like topics you want us to cover in the podcast, things you want us to cover in mentorship and mastermind. And with that, let's get going. So I just got back. You guys should know, we just got back from the Shaw Classic. We were 4.0 Solutions was a title sponsor of the deadlift. You guys know that we had developed a vision system, sort of as like a hobby project. Actually, for those of you that are watching right now, is talking about this vision system that we've built, which is really for industry, but we use technology from manufacturing to do it actually. Is this of interest to you guys? I mean, is this something you want me to cover and touch on, and how we parlayed, how we took what it is we learn in manufacturing and we apply in manufacturing, and we applied it in a really a consumer space. So it is interesting. Like, there's a video we did where we talked about why we went to the Shaw Classic. It was like a 60-second promo. All right, cool. So I will cover it. I just want to make sure that if I'm covering it, it is stuff that you guys want to hear about. So I'm gonna give you the details on where this whole thing came from. By now, for those of you who haven't watched the video, where I did a reaction video Sunday morning when I got back home, just a quick, and uploaded it to YouTube to say, here's basically what happened. The vision system that we developed, is in my original goal was to help me and my sons get better at weightlifting using vision to monitor us. So one of the things you'll see like in the gym, and this applies in manufacturing. The approach I took for this is exactly what I do in manufacturing. And it was kind of funny. The application where we built a little box that's got a camera on it and it basically monitors us while we're lifting. Okay. That application came from an application in tier 1 automotive. So actually tier 1 and in automotive manufacturing. A couple of years ago, we had seen a vision system that had been developed to track ergonomics for manufacturing workers, for manufacturing workers who is the you suck guy? Let's get rid of the you suck guy. What do you say? So let's go ahead and remove the you suck person, and we'll report him. Bye-bye. Okay. So what we did was we took this, so what we did was we took this user, or we took this application that had been done in, sorry, there was somebody spam in the chat, so I got rid of them. So what we did was we saw this application where they were doing like ergonomics. They were using a vision system to monitor ergonomics, right? And I said, oh man, I could take that application and we could do it in fitness. So but my goal ultimately was I wanted it to be as cheap as possible. So super, super, super inexpensive. Okay. And so what we did was I used a single board computer. I used a CSI camera, a high-end Sony sensor, but through CSI connection into a single board computer. Installed a Jupyter notebook. Loaded in some Python-based Facebook and Google machine learning libraries, and then basically what the first step was to, hey, can I see when somebody's getting ready to do a deadlift? Can I at least train a model to recognize that somebody's walked up to a bar and wants to do a deadlift? Can I do the same thing for the bench press? Can I do the same thing for the squat? Just three different lifts. That's it. And then all the various variants. That's the first thing we did. And if we did that piece to start, then what we could do is we could then monitor the individual lifts, and we could we measure force? Could we measure velocity? Could we measure hand placement and ergonomics? And then if we could do those things and store the data off those types of lifts, could we then predict whether that lift was going to be successful, not successful? Like, are you going to be able to lift that weight, not lift that weight? If you can lift that weight, what's the weight you could lift? Not do through normal math, but like measuring force. If I'm lifting, doing a deadlift at 350 pounds and I have, my force is X and my velocity is X and my rate is Y, then what does that mean? What's the weight that I could actually do, right? So we tested this. It took about 6 months to develop, 1,000 hours of development time. And, we reached out to Brian Shaw and asked if we could sponsor the deadlift. And, I got to tell you, we have a documentary that's coming out. We had a documentary crew come with us and document the whole step of the way. I mean, we spent thousands of dollars just getting the documentary done. I think, in fact, it wasn't really that bad. I think the budget for the documentary was like $4,000, right? So we brought a crew. We had a filmmaker and a producer along with a production assistant that came along and basically filmed everything. It did like 50 hours of 4K footage. We got to interview all the athletes. It was a really amazing experience. And on the Saturday morning, we got to the arena early so we could get set up. We used a little Jackery device, and we set up 2 cameras, one that was doing high-speed 4K video that was going to be our backup going into and then the other thing was the unit itself. If you watch the Why Are We at the Shaw Classic, there's a clip that shows you the unit. The unit's just a little single board computer with this camera. I mean, basic minimum hardware. Okay. Now, because I did that, there were limitations to my application. Like, I couldn't overlay the processed data on top of the rendered video. So if I wanted to stream the video as the camera was seeing it and put it in the notebook, but then overlay the data on top of it, there just wasn't enough processing power. So we were doing it in 2 stages. So we were doing processing and then we were doing rendering and then we were processing later, and then we would just not render and just process. So during the competition, I was connected to the camera over on my MacBook through a Jupyter notebook. I built a little UI so I could monitor the data. I was trying not to hit the camera, hit the device too much, because it was using CPU cycles in order to serve me the data. So I was just looking at the snapshot at the very end through an MQTT broker, through the unified namespace. And what's crazy is there were basically 6 rounds of lifting. So it started at 900, they went to 950, 1,000, then they went to 1050. Nobody did 11, they went to 1150, and then they did 1210. There were 6 rounds. And we predicted that the system predicted that 3 of the athletes were going to be able to break the world record. Okay, and way ahead in advance. So I think on the second round is when we had the first prediction that, hey, this lifter right here, based on force, based on all the data we collected, can do 1,272 pounds. The world record was 1,202 pounds. And so the world record was actually broke at 1,210. We predicted many rounds before the 2 lifters who actually attempted the world record weight that the world record could be broken. Okay, that it would be broken. And everybody in our section knew. We told them, hey, they're going to break the world record today. There were actually 3 athletes who had been lifting, where our data had calculated that they could break the world record that day. 2 of them attempted it. Okay. 1 of them failed, 1 of them succeeded. And the third guy who we predicted, he faded before he ever got to that weight. And so what are the implications? Well, the implications are Constantine, the guy from Georgia, he had the ability to do that weight, and he probably doesn't know it. We never talked to him because he didn't speak very good English, so we never talked to him. But we did talk to Gabe Pena, who was one of the lifters who did the lift and failed. And the reason he failed was because on the 1,150 pound lift, he used up all the energy he had, and his velocity was much lower. His force and velocity was much lower on the world record lift than it was. Now, the velocity obviously would be lower, but the force should not have been lower off the floor. And it was. And it was because he gassed himself on the 1150. And so we told him afterwards. I didn't tell him. It was on Sunday. I think Josh is the one who met with him on Sunday. I was already gone. I had left Saturday night. They told Gabe, hey, you could have done it. In fact, we measured that you had the capability to do 1,270 pounds. But we measured that at the 1,100 pound lift. What it is you did too many lifts. He had the ability to skip. He just didn't, because he wanted to make sure he could get the lower weight. What I'll say is this, is the athletes were totally stoked. And no question what we did is a game changer. And what we did was we took an application from manufacturing and we applied it in the fitness industry. And like everybody we talked to, if you guys want to see the event, you can go to theshawclassic.com and there's a live stream you can purchase. I think it's $14.99. And if you watch the first event on day 1, that's the deadlift. You can watch the whole event. You'll get to see, in fact, the MC, he does a big announcement about our company. I think maybe after the first round, he actually talks about the technology we're using. The live stream cuts to a camera shot of our system set up there. So if you guys want to see it, you won't be able to see the data because it's only on my laptop. But you will get to see like what we were processing, and we were letting the athletes know. We let Brian Shaw and those guys know. But if you want to see it, you can actually watch the live stream. And I think you can buy each day separately. So if you only wanted to see the first day, it's like $6.99 or something. But you can see how they announce. You'll see our logos everywhere. When they do a replay, it says this replay brought to you by 4.0 Solutions. I mean, it was really, really awesome. I mean, it was just an amazing experience, and it far outweighed what our expectations were. So the obvious question is, where do we go from here? Okay, what do we do next? Well, obviously a vision system for the fitness industry is not my top priority. I mean, it was really more of a what is possible. We talk about this all the time in Industry 4.0. Think about what's possible and then make it a reality. And we've sort of followed the Steve Jobs model, where Steve Jobs says, don't start with the technology and create a product. Start with the customer and work your way back. And that's exactly what we did. We started with what is missing in weightlifting, right? And the answer is, if you watch serious lifters in the gym, they all are recording themselves while they're working out and then watching that video back. They either have friends recording them, or they're recording themselves, setting it up on tripods. Sometimes they're sharing it to social media, but a lot of it is they're trying to self-critique manually. It's that's the spreadsheet approach that we see in manufacturing. What we said was, what if we could just use vision to automate that process? So instead of them having to watch the video, what we could do is watch the video and then get context from the raw data in that video. And what was amazing was Google and Facebook had developed technology where you could train a model to essentially create raw measurement data from an image moving on a screen. And we process it on every frame. So we record the video at 60 frames a second. So our model runs 60 times a second on each individual frame. Then there's a model that compares the data that comes from each frame. There's a model that runs through and is looking for patterns across each 60 frames, right? So it was, I did all the development myself. There was no other engineer who's written a line of code yet. And while I'm a good engineer, I'm not the person who should be doing that. I don't do products, that's not my, but I do a lot of prototyping and a lot of like betas and, alphas and betas, and getting you right to minimum viable product and then turning it over to other people who harden it and commercialize it and all that kind of stuff. So, have we used Edge Impulse? The answer is no, other than I've been reading a lot about Edge Impulse. Good question, Kirthana. All right. Any questions about the Shaw Classic thing, the vision system? What's next? I don't know what I'm going to do with it yet. What I do know is we're going to sponsor the Shaw Classic again next year. And our goal is to improve the system so that it can be used in the broadcast. So while they're broadcasting over the live stream, or maybe even on the Jumbotron, they can, we can, hold on, I want to answer John Maldonado's question. What we want to be able to do is superimpose the data onto the live stream next year. So during the deadlift, people will be able to see, predictions. What we predict they're going to be able to do X weight. This is what the amount of force was. This was their velocity. This was the time to azimuth, right? John Maldonado, can you tell us about the stack for the lifting system? Can you clarify what you mean there? Like, what is the underlying? I actually have a graphic that shows how it's actually built. But are you talking about the software stack that we're using? Because if it's software right now, I don't know what we're going to do for the front end. Yeah. Okay. So, all right. So the back end is Hadoop, which is storing all the raw data. The model, the front end is Jupyter Notebook. So there's really no UI right now. That we're using a Jupyter Notebook to kind of create a UI, but I don't know where I'm going long term. The code base is all Python. And then there is a Mosquito broker. There's a Mosquito broker that the Python code base is publishing data to. There's 70 something libraries we're using, I think. 70 something libraries, give or take. Hair over 100,000 lines of code. Just broke 101,000 lines. There's a lot of refactoring that needs to be done. There's a bunch of technical debt in there. But it's Hadoop on the back, Python in the middle, and Jupyter on the front. But it won't be Jupyter long term. I mean, TensorFlow, are we running that local in the Brick PC? Yes. Where did that come from? I don't see George's comment in there. Oh, all right. Matt, can you tell us the single board computer that you used? You guys aren't going to believe this, actually. Thanks for your work. You get me excited about seeing all the maker stuff that I play with being used. Did I use TensorFlow? Yes, John Maldonado. I use TensorFlow. All right. So the answer is the single board computer is, I'll give you the exact specs on it. So we are using the Jetson Nano. Okay. The 4 gigabyte Jetson Nano, which is why I continue to, that's why we're running out of CPU. We are going to upgrade because the 4 gig Jetson Nano just doesn't have the horsepower we need. We are running the instance fully in a Docker container. So and really we just did that because we followed NVIDIA's model for vision machine learning applications. Any other questions about that? All right, cool. All right, let's move on to MES. So by now, you guys should all know that we're doing MES Bootcamp, which starts next month, and it's really Benjamin, how did you model perseverance? I've seen what will to never give up can do. I don't understand the last. Benjamin, what we can do is we can have a offline call, and I can take you through all of my modeling diagrams and answer your question. All right. So by now, you guys know we're doing an MES Bootcamp next month. The early bird ends August 22nd at midnight. So that is, it ends at the end of the day this Sunday. The first session will be September 17th. We still haven't settled on the time. That is when we're going to start. My plan had been to do 8:30 Central to 12:30 or 1 o'clock. We might start a little later if it's better for people. We can start a little earlier. We just haven't settled on that exact time. There's a whole video on what we're going to do in MES Bootcamp, where we're basically going to teach you how to build core MES using Ignition, Python, and SQL, the core MES capabilities. And so this is one of the things we're going to talk about in Mastermind on Friday is we're going to talk more about the details of what is MES. And this is a really important point. Okay. And I've said this many times, I'll say it again. MES is not a product. It's a quilt. Okay. It's a quilt of capabilities that you put together. But if we wanted to say, what is a manufacturing execution system? The best way to describe manufacturing execution system is to say it this way. It is the place where a sales order gets converted into the execution of manufacturing. That's what MES is. It's a place in the model. Okay. Kirthana asks, do a lot of customers ask for a custom MES? And what are the benefits over and off the shelf MES? We're actually going to cover this in the MES Bootcamp and in Mastermind Friday, but I'll give you the answer here. Okay. If you buy off the shelf MES, you will be disappointed. Okay. Generally, the way that this goes is an organization they'll start by trying to buy an off the shelf MES, right? And then there are capabilities that they need that are unique to their business that off the shelf MES can't provide. Manufacturing execution system it does not consume the structure of your business from the ERP and then impose that structure on your manufacturing operation, right? So if you think of like order of operations or your manufacturing steps, right? You generally define those in your ERP system. Okay. And they're static. They're not flexible, right? This is the way it's supposed to be done. But what happens if you can't do it that way? If a machine is down or, an asset is down, how do you handle the flexibility? And the answer is you just sort of don't. It doesn't mean that you're going to go, oh, because the ERP says I'm supposed to do the work on this work center. And I can't do it on that work center because it's not running. It doesn't mean that I'm not going to move it to this other work center where I know it can work. Or let's say we define a production line as cell A, cell B, cell C, cell D. And then line 2 is cell E, cell F, cell G, cell H. And I go through and I process my work and flow is A, B, C, but cell D goes down. And I have the ability to move everything from D by hand over to the end of the other production line to finish it. I'm going to do that. Okay. Even if it means I got to set up a temporary conveyor or however I'm going to do it, I'm going to do that. My ERP system isn't designed to handle that, right? No ERP system, by the way, is designed to handle that type of change. One of the mistakes that we make, to answer Kirthana's question, one of the mistakes that we make is that we believe that all manufacturing happens the way it is theoretically designed to happen. Definitely people on the carpeted side of the business believe that. But anybody who works on the concrete side of the floor, the business, knows production is king. No one gives a shit what's in the ERP. We're going to produce. And we're going to do whatever it takes to produce. So what does that mean? What it means is that your manufacturing execution system should not be designed to enforce a model that exists in the ERP. The MES system should be a reflection of the reality on the plant floor. Okay? And so what ends up happening? When I buy an off-the-shelf MES is designed to enforce the model that lives in the ERP, the master data model, the structure of the business, the material management, all that. But the reality is that there are edge cases that have to be accounted for. There are capabilities that customer A needs that customer B doesn't need. There are capabilities that plant A from customer A needs, but plant B from customer A doesn't need. Okay? The truth is that MES should not be rigid. It should be designed and built to be a reflection of your reality, not impose theory on your reality. So not from the ERP down, but a reflection of what's actually happening on the plant floor. No one has ever said this. Okay, this is something that's never been said. No operations manager or production supervisor or machine operator has ever said, we can't do it that way because the ERP doesn't say we can do it that way. No one's ever said that. No one has ever said we can't do it that way because the MES system doesn't say we can do it that way. And if anybody, I challenge anyone here to prove me, if I'm wrong, tell me I'm wrong here. No one has ever said, oh no, we're not going to run it on that machine because the MES system doesn't say that we can. No, production's king. Okay. So nearly everybody, I don't know anyone who doesn't eventually move to either a hybrid MES, which is a combination of off-the-shelf features plus custom features married together. This is why using an IIoT platform, a platform for solving problems, is so important. Where you can build things and you can put things you built right alongside things the OEM built. You can put them together in the same screen, right? But most people, very, 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 very few customers are satisfied with off-the-shelf MES. Very few. Now, and that's why what you'll see is I may have off-the-shelf MES for these 3 capabilities, like OEE calculation. And then I've got another platform that's giving me these 4 capabilities. And then I've got this homebrew application I built that's giving me these other 8 capabilities. But if I add all those capabilities together, that's the quilt that makes up my MES layer. But they're in 3 different places and they don't interoperate with one another. Part of what we create, what we encourage people to create is that hybrid version of MES where you can take homogeneous features, Homogeneous means it's uniform across the entire organization, and put them right alongside heterogeneous features, which are customer unique, in the same place. Same screen, single pane of glass, in the same unified namespace. Okay. Doug Albright, many think of MES as OEE and related KPIs, but the MES standard was primarily made to integrate into the ERP layer. Will you be covering ERP integration in the MES Bootcamp? Yes. We will not be integrating to an ERP, but we are going to show you how to integrate to an ERP as a consideration. Okay. In general, and we're going to be using a business connector within the Ignition platform to do that. Good question, Doug. Youssef, is there a must-have and nice-to-have list functionality for MES? OEE is basic must-have if we are to evaluate on off-the-shelf MES. Okay. Outside of status, so that is cell, line, area, plant status, TEEP, OEE, and downtime tracking. Outside of those four things, okay? Those are the four that you are always going to do. Everything outside of that is optional. I mean, I would say work order management is probably used in 90% of the applications. At a minimum, you're consuming work orders from ERP. I would say scheduling 50% of the time happens in the MES layer. 50% of the time it happens in the ERP layer. It should happen in the MES layer, not in the ERP layer. You should schedule an MES push to ERP. And the reason why is because you're going to have to push schedule changes from the manufacturing floor to the ERP in your edge cases anyway. So that should be your standard, right? So if what you do is assume that the schedule is always going to go from ERP down to the manufacturing layer, down to the machine layer, if you think that that's what's going to happen 100% of the time, you're kidding yourself. Even companies like Toyota, who they have one of the most advanced custom ERP, MES, CMMS layers in the world, their ALS system or ASL, whatever it is. Even Toyota, who manages every one of their production facilities from Japan and pushes the schedule and work orders and bill of materials and everything from Japan to their facilities here in the United States, even they have edge cases, and they have edge cases they can't account for. Okay, so it needs to be inverted. You know, the schedule really needs to happen in the MES layer and be pushed to the ERP layer, so that what you've done is you've architected a way to push the edge cases, the deltas, to the ERP when they happen. Okay. I got an email. So after we announced the boot camp, I got an email from an old friend, a guy I respect a ton. I'm not going to say who it is because I didn't give him a heads up that I was going to read the email. But anyway, he said, I want to read this because he brought up a bunch of good points about MES. Okay. So number one, he said, Walker, this sounds like what we tried to do at Enter In Company Name, only to fail. Before anyone attempts to build their own manufacturing execution system, I would strongly suggest a realistic assessment be done of, number one, what are the short and long-term must-have and desired capabilities? Yep, I agree. Number two, why not use an off-the-shelf solution if there is such a thing? Number three, what is the desired time frame? And he put in some points. This should also include an assessment of maintenance. Anything is possible, and with eyes wide open, you can build a focused MES solution. May still be the best approach, but it may not be the fastest. Okay. And so this is a really important point. And this is one of the real challenges in MES, especially as it relates to digital transformation. So let me back up here. Remember a couple of foundational elements. Digital transformation, okay, becoming an Industry 4.0 company, becoming a company where data is your primary commodity, becoming a company that plugs into a digital supply chain, becoming a company that can recruit and retain the employee of the future by allowing the employee of the future to identify and solve their own problems in a common digital ecosystem, okay? If you want to become one of those companies, your journey starts with education. And very early on, in not only do the individuals get educated, but the organization gets educated. And what you want, if you look at his original statement, which is, what are the short and long-term must-have and desired capabilities? Okay. In order for you to do a realistic assessment of what you want, you must first acknowledge what it is you do know and what you don't know. Because in digital transformation, what you want is a function of what you know. I can't ask for if my education, my knowledge, my vision isn't broad enough, I can only ask for things. I can only try and solve problems I'm aware of. I also can only suggest solutions to problems that I'm aware of based on what I know is what is possible. During digital transformation, you become much, much smarter very quickly. That the learning curve is it's very steep. If you look at the technology S-curve for continuous improvement, you get smart really, really fast as an organization. And if what you want is a function of what you know, then it naturally follows that what you want is going to change at the same rate your knowledge goes up. Okay. That's a mathematical, we can prove that. Okay. So not only do you have to do a realistic assessment of what your short and long-term goals are, your must-have and desired capabilities, but you must do a recurring realistic assessment. This is why being an agile organization is so important, right? Being agile, accepting that just because I said we want to do something today doesn't mean we're going to want to do that 2 months from now. Okay. And this is a really, really, really important point. Okay. It's super important point that you must be doing not just only realistic assessments in the beginning, but you must be doing them iteratively throughout the process. You also need to be documenting them. One of the things that we love to do is when we'll do I will do this generally. I'll do a check-in with our clients. I'll come back a year after, our team's been working with them for a year, and I'll come back and we will basically we'll visually show them how much smarter their organization has gotten just based on the things they've requested. And I strongly encourage integrators to do this. Show your customer how much smarter they are just based on the things they request. When you first engage, Mario Ishikawa must see this because I know Mario is, big time engaging with a bunch of different companies at the beginning of their journeys. Dave Schultz is doing the same thing. John McKeon at GIS, they're all seeing the same thing. In the very beginning, when you're engaging with a client, that client has a very narrow list of things that they want. They have a very narrow view, and it's because they are, for the most part, pretty blind in terms of what the possibilities are with digital transformation. And then as you're engaging over time and you're making your clients smarter, they engage with you a lot more, and they have much stronger opinions about capabilities they want to see. And the volume of capabilities they request goes up. And you can plot this. I mean, you can show them, hey, you're getting smarter. That's what this means. As an organization, you're getting smarter. Okay. So what that means is you need to go in with your eyes wide open that, hey, just because I want something today doesn't mean I'm going to want it a year from now. Liam Doyle, should an MES system be designed with the capability to update the production model to reflect the changing reality of the shop floor? An MES with a better modeling system will allow flexibility. The answer is yes, but just like in any, your production, you should never delete anything from your production model. You can hide things, you can extend, you can expand your production model, you can edit your production model, but you should never delete anything from your production model. Okay. So, and it's a general rule like in databases, right? You can add columns, you can add tables, but you never delete them. It's the same thing in a production model. Now that doesn't mean when you do like a major release of your MES system, you don't want to, you may want to go in and do inventory and call out, definitions that are in your tables. But yes, your production model is going to grow. It's going to extend. It's going to become modified. But let's say that I change the asset ID something as simple as changing the asset ID of a machine. What I'm really doing in that case is creating a new asset and then disabling the previous one. But yes, absolutely. An MES should be designed with the capability to update the production model to reflect the changing reality. But that doesn't mean deleting anything in the record. All right. How to validate or qualify a complex MES system possible with cloud AI technology in a highly regulated pharma industry. Do you have some thoughts about the FDA requirements to these complex solutions? All right. So let's talk about pharma here for a minute. There is no greater shit show on the planet than manufacturing execution in the pharmaceutical industry. That's by far the greatest shit show. My engineers, nobody on our team wants to work in life sciences. By the way, nobody wants to work in life sciences. It's a fucking nightmare. If you're if you're a really, really great engineer, you don't want to be in life sciences. Okay. 80% of the work is documentation, the bureaucracy, the lack of agility. I mean, I'll say this. I've never seen the pharmaceutical industry be so agile than as it was during the pandemic. I mean, all the rules went out the window when it came to like developing the vaccine, and that's the simple truth. And we saw, we got to witness that with our own eyes. And anybody who works for the companies that make the vaccines will tell you, hey, listen, there were definitely exceptions, and we definitely prioritized getting, approving things and stuff. So there's a great story about MES and pharma. Rockwell Automation partnered with a bunch of pharmaceutical companies to build an MES system for the pharma industry. And they spent hundreds of millions of dollars. The pharmaceutical companies and, in conjunction with Rockwell, spent an absolute fortune to build the single greatest piece of shit MES system I have ever seen in my life. Okay. Absolute piece of shit MES system. Garbage. And if you talk to the people who work in pharma, they'll tell you it's garbage. They'll tell you right in the meeting, it's garbage. Okay. It is the consummate data silo. Okay. Here's the unique challenges there are two unique challenges in pharma. One is the regulatory component, where the vast majority of engineering gets hung up on validation and documentation, right? Rightfully so. You're making drugs that are going to people's bodies, but it increases the amount of work, by a factor of probably 4 or 5, just in validation and documentation. But the other challenge is that pharma is the only industry where manufacturing is not centered around ERP. It's not centered around MES. It is not even centered around individual products. It's centered around a very something that is unique to pharma, and that is the batch record. So the center of the universe for all data is batch record centric. So the batch record is basically the genealogy of how a drug is being manufactured. That's what it is. If I wanted to look at the genealogy, that's what it is. Yes, ACOs. Pharma is a shit show, especially on the MES piece. And I mean, you're not going to find anybody who comes on and is like, oh yeah, it's fucking amazing. I love it. Nobody says that. We treat life sciences very much the same way we treat oil and gas. So oil and gas, life sciences can help fund technological advancement because pharmaceutical companies pay a premium for their solutions. And they pay a premium because it's such a pain in the ass to work with them. And your engineers, you run the risk of turning over your engineers if you put engineers on life sciences. So the best engineers in the world, they don't want to work on life sciences projects. And it's not because they don't want to work on them because they don't move fast enough. Like if I'm a world-class engineer and I go work for Tesla And my buddy, who's a world-class engineer, when I say that, I mean full stack, somebody who's in the 90th percentile or greater in terms of total productivity in the full stack. Okay, that's your world-class engineer, right? If I go to Tesla and my buddy goes to a pharmaceutical company and we go back and we talk to one another 5 years later, I'm way, 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 way ahead of the guy who's been stuck in life sciences purgatory for the last 5 years. It's not that the people in life sciences aren't smart or gifted or anything, because they are. But do the world-class engineers want to work there? Fuck no. Hell no. Nightmare. Nobody wants to spend 80% of their time on documentation. Nobody. No one wants to have to revalidate something that they know is fucking correct. And they don't want to have to revalidate it 15 times. Okay. But the interesting thing about MES in life sciences, and the real challenge, is centered around the center of the universe is the batch record, and life sciences is the only industry where that's the case. And so everything about life sciences is very unique. So what is the path? What's the way that you should attack life sciences? You don't do it on the commercial side. We only recently realized this. So in the last couple of years. So when the pandemic first started, we were working with one of the companies that was doing the vaccine. We started right away with them, I think like in April of 2020 or maybe March. And we were using our architecture, and so we knew the vaccine was ready like in August or whatever. And I ultimately decided to use their vaccine because I was able to ask questions of the people who work there, like what percentage of the leadership is getting them and all that kind of stuff. But because we were on the commercial side of the business, things advanced really, really slow. Like they spent $250,000 and took like a year to get where they should have gotten in 90 days, and spent $60,000. Like that was the rate. That's how slow things moved. But what we realized was we started partnering with a life sciences company based in Europe who has digitization of the batch record is a big question. I sent a BR question to your team. So real quick, ACOS, or I think it's ACOS. So what we're doing is we are creating a life sciences SME group out of the Discord, out of the Industry 4.0 community. It's going to be made up of people from Intellic Integration, 4.0 Solutions, GIS, so Galeris Industrial Solutions, and Skellig Automation, and anybody else who has expertise in life sciences who wants to join this group. And we're going to attack life sciences as like a single-headed monster, right? Digitization of batch record, ourselves, Skellig, and GIS all worked together on a proof of concept to do this very thing together as just a group. I don't think we even did it. Oh, it may have been done for a client, but I wasn't part of it. Another one of my engineers was. But digitization of the batch record is really the same as doing track and trace for discrete manufacturing. It's the same application, right? Matt Kendall, O&G SME Group. Yeah, let me go back to the oil and gas piece. Oil and gas and life sciences are the same, right? They are the industries you use to fund technological advancement for discrete manufacturing. So life sciences pays a premium. They're a pain in the ass to work with, but they pay a huge premium, and they have the money to invest in technological advancement. Same thing with oil and gas. Oil and gas is a pain in the ass to work with. It's not because they're bad people. It's two reasons. In oil and gas, it's feast or famine. So they have lots of money for a short period of time. Okay. When they have no money, they don't invest anything. When they have a lot of money, they invest everything, and they wanted it yesterday. So the moment oil and gas has a lot of money, they'll pay a massive premium for you to develop great technology for them, but they want it fucking yesterday. And they don't care that your wife just gave birth to a baby, or, their jobs are really, really hard, and they have no sympathy for your real life. So it can be an absolute, oil and gas, all good people, but it's either feast or famine. And when they've got the money to spend, they're going to spend every penny of it, and they want the work done yesterday. and it really drives engineers crazy. Okay, it's Matt Kendall, missed my son's birth and like 8 Christmases in a row. Let me say this. I'll tell you a story. Maybe 7 years ago, I celebrated Christmas with my entire family in a hotel in Victoria, Texas. So on Christmas Eve, I was doing a runoff in Midland with my family. We planned this whole thing. So I had 3 days leading up, and then Christmas Day, and the next 3 days, I was doing a runoff in Victoria. And we literally used the Christmas tree in the hotel lobby. And like, we put, Christmas music and stuff on the TV. I mean, we made the most of it, but I was lucky. I was one of the few guys who had my family with me. All the other guys who were there doing the runoff, their families were doing Christmas without them, and they were there working. I was lucky. My family came with me. I had my kids with me and my wife, but in oil and gas, when they got the money, they spend it, but there's no days off or anything like that. So it drives you nuts. But the advantage is they fund the technological advancement that you're able to then parlay in other industries, right? It's the same thing in life sciences. Here's the trick in life sciences. Here's what we've learned. You move to the R&D side to do the advancement. So every single life sciences company, they have 2 groups, or at least 2 groups. One is the research and development side, and one side's the commercial side. Whenever they have a product that's come out of trial and they're getting ready to mass produce it, the first place they test mass production is in their research and development facilities, where they have much smaller bioreactors, but the process is set up the same way. But none of it's regulated the way the commercial side is. So the mistake everyone's making in life sciences is they are going to the commercial production side to do the advancement. They shouldn't. They should do it on the R&D side. They should start by digitally transforming R&D. Then they apply what they've learned in R&D to the commercial side of the business. And we're doing this at scale for a really large life sciences company now. And the speed at which we're able to move is 4 or 5 times the rate we were able to move with that other life sciences company. Monty Python quote, "You were lucky." Oh yes, I was lucky. I had my family with me. All right, let me pick one of these that I want to go through on the MES side. I have 3 that I can choose from. Let's do this one. So Benjamin, so he sent a thing in Discord about MES, and he said, "Hey Cheryl, how are you doing? I need some information." So number 1, I need to ask if you can provide me some information related to MES 4.0. Okay, for those of you who don't know, MES 4.0 is our MES system that we use with our clients. So I can't really think. I mean, maybe there's one client right now where we're not using our MES. We're using something else, but MES 4.0 is basically core capabilities that we then extend for the client, and it's all built on a unified namespace. What we're going to be teaching in the MES Bootcamp is basically teaching you how to build your own MES 4.0, but not without all the features that we have. Like we have digital work instructions, and there's lots of things in our MES 4.0 we're not going to teach in the bootcamp, but we're going to teach the core stuff. And the methodology that I'm going to teach you is the methodology used to build MES 4.0. Okay. I need to ask if you can provide me some information related to MES 4.0. I am consulting an apparel manufacturer, and part of this project is to suggest the roadmap and technological interventions to help them smoothen their transformation journey. I've been looking for MES solutions for apparel manufacturing, MES solutions, but no available solutions truly are MES. In this regard, can you share information related to MES 4.0 and whether it will work in apparel or not? Also, if there are other solutions available, let me know about them too. All right. MK Ultra, is this MES course worth it if I am not experienced in ignition? The answer is yes, as long as you're experienced in Python and SQL. There's a video we shot that was like an FAQ, and basically it said, if you have high fluency, you got to be familiar with ignition. You got to know what it is. You got to be able to install ignition, but I'm obviously going to show you how to do that. So you're going to be able to follow along while I'm developing. But if you're fluent in 2 of the 3 in the stack, you're going to be fine. So if you're fluent in Python and SQL, but not in ignition, you'll be able to fill the gap. If you're fluent in ignition and SQL, but not in Python, you'll be able to fill in the gap. Okay. So it's really 2 of the 3 pillars. If you're fluent in 2 of them, then MES Bootcamp will work for you. So Cheryl said, your question is good timing, Benjamin. I'll add to the questions Walker's planning to discuss in the podcast and the next mastermind meeting. Can you tell more about the specific problems this manufacturer is trying to solve? There's many changes going on in the clothing industry, et cetera. And Benjamin said, well, this customer is probably at industry 2.5. Right now, they only have ERP in place. All production planning is manual and on Excel spreadsheets. I want to implement an UNS and an MES solution. Like Walker says, one should always build MES until that happens, which is quite far. I was going to implement the next best. Apparel industry is labor intensive, so there are no PLCs, people operating stitching machines. And I am also working on some way to acquire data automatically the moment it gets generated. All right. So little known fact, MES 4.0, when we built the solution, it was originally meant for companies that didn't have PLCs. MES systems generally were good at one and not the other. So they were good at either consuming the data from technology or consuming the data from people. We built core MES and MES 4.0 with the ability of being able to marry together manual input data and automatic data at the same time. So you are on the right track. You definitely want to go with some type of custom MES where you're going to be able to consume events from people. Okay. The best way to do that is to automate the consumption. So you want to have administrative controls that enforce that operators do certain things. And then the engineering controls are what you're doing in MES to consume those things, those events. And then I'm going to close out with this comment from Sam Gupta. So it's Sam Gupta, WBS Rocks. He said, there are many considerations depending on how you'd like to design your architecture. And he's talking about ERP. He says, the ERP needs, well, let me comment on Doug Albright here. Doug says, is it fair to say that MES is not really an app, but it's data ops, which is critical to migrating into the digital supply chain? The SQL MES package just can't scale as a message queue, nor SAP ECC. The answer is, man, I hate riding the fence. I would say MES at face value is a reflection of the reality on the plant floor. That's what MES should be. Number one, it should be a reflection of the reality on the plant floor that takes into consideration the context, the theoretical context, rules, and constraints that exist in the ERP layer. So the structure of the business, the asset IDs, standard rates, scheduled rates, changeover times, all the standards, right? But MES at face value should be a reflection of the reality on the plant floor, which therefore makes it more data ops than it is application. Okay. And it is critical. The vast majority of the data that you see in MES is abstracted. An abstraction is context created from one or more data points. Okay, we're cleaning it and abstracting it so it means something. It informs us. So in that sense, it is definitely data ops. Okay, but its purpose is to give us insight into the reality on the plant floor when we compare it to the standard set in upper layers in the stack. Okay. Akos Ruska, do you use manual input option in MES for collecting data from operators? Yes, we will collect data from operators manually. With part of the reason we use the unified namespace is sometimes we're collecting from machines and people together. Sometimes your waste number is a combination of what the machine tracked plus what people entered. So we're marrying the two together in some cases. But yes, Benjamin, a customized tablets to take user inputs is the most common solution. Correct. All right, so let's go back to Sam Gupta and then we'll call it a day. He says the ERP needs at least contextual information to be able to control inventory, costing, and scheduling. Some people might argue that scheduling belongs to the MES or shop floor systems, but you need to define a clear boundary of who is responsible for what. No, Sam, you're wrong. You do not need to provide a clear boundary. You need to account for both. This is just like saying, because here's the reason why you don't define a clear boundary. You could say that all day long, but there's not a single person, no one who has experience in manufacturing, especially on the plant floor, who is not going to agree with the following statement. If the ERP tells me I'm supposed to do something a certain way, or the MES system tells me I'm supposed to do something a certain way, and production realizes that that is wrong, they're going to fucking do it the right way no matter what. They're going to do it to keep producing no matter what the ERP or the MES system says. Okay? That is just the absolute truth. Production is king. Okay? So it's very easy for us on the IT side to say clear boundaries of who's responsible for what, right up until the moment the edge case presents itself. And those boundaries just evaporate. Woof. Just like all the regulations that applied to life sciences evaporated when we had a pandemic. Okay? We have to be honest with ourselves. You can create these, you can create boundaries all you want, but if you can't enforce them, or moreover, you're not even going to acknowledge that, hey, listen, if the boundaries we created prevent us from producing, we're going to produce anyway without changing the boundary. Well, then what you've done is you've created a scenario where it's possible to do things on the plant floor that don't align with your digital strategy. The digital strategy has to account for all the edge cases. Okay, it's very important. That doesn't mean you don't need to define boundaries that you want to try and live by. But saying that you want to define clear boundaries of who is responsible for what, in terms of which applications are responsible for which data, is a fool's errand. It's a fool's errand, because the future is a flat stack. The future is a completely flattened stack, not a stratified stack. It is a flat stack, and that's what we're moving to on one common infrastructure. And what data exchange needs to happen in both systems to facilitate this collaboration? I agree with you in IT. On the IT side of the business, I agree with you 1,000%. Okay? That you need to define a clear boundary as who's responsible for what, and what data exchange needs to happen in both systems to facilitate that collaboration. Yes, in IT systems, 100%. But that is not the way the world works on the OT side. On the OT side, it does not fucking matter. If I say that machine is the only machine that's going to produce this subassembly to send to that machine, and that machine doesn't run anymore, it explodes, somebody cut an arm off, they're not going to stop producing the thing that goes on the other machine. They're going to figure out a way to create that subassembly. That's what they're going to do. And you have to have a digital infrastructure and a digital strategy that accounts even for the edge case. That's why edge-driven matters. Number 2, inventory and master data are where all the problems start with the best-of-breed systems. Agreed? 100%. So as long as you have a clear state of the inventory and product data and how that will be used by the downstream systems, such as the shop floor, is critical for the success of the architecture. It doesn't matter which path you take, whether you would like to go for best of breed or integrated, as long as you have a clear understanding of the roles and responsibilities of each system and how they will be collaborating on the shared data. I disagree. Obviously, if you are buying integrated systems such as ERP, it will always be less expensive once you account for all the costs. The more integration points, the higher chances of failure, the more expensive it gets. Here's my point. My point is this. The boundaries you set are in the unified namespace. This is what the structure of our namespace is. This is what our functional namespaces will look like. Okay, this is the definition of our functional namespace. Our MES namespace, our OEE namespace is going to look like this. Okay, your boundaries are there. What you're arguing is that you have to set clear boundaries between applications. No, you don't. You don't even need to know all the applications that are being used. Let me say that again. You don't even need to know all the applications that are being used. I got this question about, hey man, we're using 3 different data analytics platforms. Can you help us pick which one we can standardize on? And I said, no, I can't. Use all 3 of them. I can help you standardize on your minimum technical requirements. I can tell you the minimum technical requirements that each of those data analytics platforms have to meet in order to consume the data from our unified namespace and publish back their results. But I'm not going to tell you which one to use, and you shouldn't be telling people which one to use. If person A wants to use analytic platform A and person B wants to use B and person C wants to use C, what you enforce are the minimum technical requirements. Let them use whatever fucking platform they want to use. What do you care? Well, how much it costs? Well, then make them pay for it. Have their department pay for it. Stop funding it through IT. That's another huge mistake manufacturers make. Why the fuck does IT own all the software? Who are the most ignorant people about SCADA systems in your entire organization? It's people in IT. Who's the most ignorant people about MES? It's people about IT. It's people in IT. Why the hell do you have them owning those systems? Owning the licensing? I mean, how does that make any sense? So what I do want to say is, this is a good point that Sam, by the way, I respect Sam a lot, but there is a philosophical difference here we have. That is, you're not enforcing applications and connections between applications, the boundaries, or even the layers in the stack. What you are doing is you are writing minimum technical requirements that you tell all those things they have to meet in order to talk to one another. All right, I just want to say, Alan Ramsey, I had a plant manager that always said production is the baby and you don't ever drop the baby. Amen, brother. Amen. All right. Hey, it was really good. Oh, hold on a second. Matt Kaufman. Could it be said that the minimum technical requirements software is constrained by the protocols you use? Yeah, it could be said. I mean, although there are exceptions. So I wouldn't say there are exceptions, but I would say that's the rule. Yep. That MTR is constrained by the protocols you use. Yeah. I mean, in most minimum technical requirements, those specification documents, it will call out a list of protocols that you can use. So you have to support at least, you got to support this one, or this one. Most digital strategies don't settle on just one protocol, but they do settle on just one infrastructure. So if let's say I'm using DNP3, which is pub sub, right? I'm still going to convert that. If MQTT is the foundation of my digital infrastructure, I'm going to convert to MQTT at some point. But that's relatively easy. All right. It was very good to be back live. I'll definitely be on. I think I'll be on live next week. It may be pre-recorded next week or it may be live, but after that, going forward, will be live. Doug Albright, I work in IT and work hard to help the shop floor. They're my customers, and it's just an admin thing. Why would ops want to manage all the details? Ops doesn't want to manage all the details. What they don't want is, this is good before I close out. When we do a digital transformation maturity assessment and we meet with the IT group, one of the first questions we ask the IT group is, are you security and compliance or are you a service organization? And they always want to say, I'm a service organization, but they'll even say that. They'll say, I want to say that we're a service organization, but really we're security and compliance. And I'll say, well, you're probably both, but which one are you first? Is your mandate security and compliance, or is it service? And by service, I mean enablement. And what does that mean? People in IT should never say no. In fact, that's a word they should remove from their vocabulary. So if you work in an IT department that ever says no, if you ever say no, then you're not a service organization. You're security and compliance first. But agree with your point, Doug. My point is that when I worked for the manufacturers, I could do the IT person's job, but they couldn't do mine. And yet they were the one who was telling me no. And how do I know that? Because guess what engineers do? They just create their own infrastructure. They literally just break off and create their own infrastructure. They'll create their own hypervisor system. I mean, they'll just build it all themselves and remove it from the purview of IT. But your point's taken, man. But also, Doug, you're also you're the exception in IT, though, I suspect. All right, everybody, appreciate you. Hopefully we can do it live next week. If not, it'll be pre-recorded. I get it, but you can't have too many applications. We try not to say no. I disagree, Doug. You can have you there's no such thing as too many apps. Like, Doug, like if you have I have two phones here, right? I have a Google Pixel and I have my iPhone, right? So you either have an Android or an iPhone. How many apps do you have on your phone? I mean, I could count. I probably have 200 on my iPhone. You may have, let's say, 100. Who are you to say that I shouldn't have 200? Like, think of it in terms of those in those terms. What ends up happening is the IT department wants to put software and applications into a neat little box, right? So they may define Ignition, for example, as a SCADA system. And they may say, we already have a SCADA system. We have Wonderware InTouch. Well, there are things I can do in Ignition that I can't do in Wonderware InTouch. In fact, there about 90% of the things that I do in Ignition, I can't do in Wonderware. But the IT department is going to say, we already have a SCADA system. You can't use Ignition. We're not paying for it. And I'm saying, shut the fuck up and buy it or give me the money. That's what I'm saying. I'm not going to sit here and argue with you about whether or not Wonderware InTouch and Ignition are the same thing because you Googled them and you saw the same word, SCADA. That's my point. You know what I mean? That's what I'm getting at. Is that in software isn't really function and capability. It's potential. Right? Believe me, I get it. They're stuck on Wonderware. Yeah, so you and I are in the same boat, brother. John Maldonado, I was once told no on an Azure function that was going to cost $2 a month. That's before they knew the cost, but still. Yeah. All right, everyone. I appreciate everyone. I'll see you guys next week. Please comment below that, if you like the way that this session went, and we'll do more of that. And if you want to know more about the vision system or any of the other details, I'll probably do an offline session and record it, and we'll put it on the YouTube channel. And I'll answer technical questions about it if anybody's got them.